Here I am using Excel to run a multiple regression model on housing prices from a jump file. We have price of the houses sold in thousands of dollars and variables we think might be good predictors of the price. We can run multiple regression in Excel. We can look at correlations of the variables with each other, but we can't directly determine what is the multicollinearity or what is the variance inflation factor, so we have to find. Since the existence of multicollinearity can distort p-values and correlations of other variables, we have to find that first. We go to Data tab in Excel. We go to Data Analysis tool, Correlation. Pick the entire data range, including price, and create output in a new worksheet. We'll go to Home tab, select the entire output, and do a conditional formatting. I'm going to highlight anything greater than 0.8. There is a very high correlation between miles to resort and miles to base. All other variables have correlations less than 80%, and of course high correlation with price is okay. So these two variables, we need to remove one of them from the model with about 95% correlation. It should not make much of a difference for the model, but we can look at the correlations they have with price or the practical importance of the variables and pick one of them. And we need to run regression models and calculate variance inflation factor for these two variables. This is the formula for variance inflation factor. The R squared sub j is the R squared of the model when we regress one of these predictors against all other predictors, which is the dependent variable will be miles to resort or miles to base, and then independent variables will be all other predictors. In Excel, the data range should be a contiguous range, so we need to copy the data into two additional worksheets. In each of them, miles to resort or miles to base will be y, or dependent variable, and other variables will be independent. Now we are ready to run the first regression model. Miles to resort is dependent variable. We go to Data tab, Data Analysis, and pick regression. Our y range will be the first column. X range will be the range of all other variables. Labels are included. An output range. I pick it here. Copy the formula here. We have the R squared of this model as 0.9276, so we calculate the variance inflation factor. which is 13.8, a very high variance inflation factor. We can also run a model for miles to base. Go to data analysis and regression. The selected ranges for y and x are already here, and I'm running this. R-square of this regression also 0.93. Variance inflation factor of 14.5. So both variance inflation factors are really high. We need to remove one of these two variables based on the correlation matrix. We know these two variables are highly correlated, so removing one of them should take care of the problem. We come back to the original data set and remove miles to base. Now we can start our stepwise regression, removing the least significant variable one at a time. Data analysis and regression, select x and y ranges. And run. We need to focus on p-values. The largest p-value represents the least significant variable. Here, days on market with p-value of 0.92 is the least significant variable in this model, so we will remove days on market. I'm going to do all analysis in this worksheet, so I'm removing the output and also the column for days on market. And run the model again. Regression. I just change the X range. Here in our new model, we'll look for the largest p-value, which is the least significant variable. Seems like bets with p-value of 0.56 is the least significant, so we'll go for removing this variable. And run our regression again. And one more time, focus on the p-values. This time the largest p-value will be for cars, 0.66. So cars will go out of the system. we run the model again. Also use conditional formatting. Select the column and under Home tab, conditional formatting, top bottom rows, top 5% will be automatically formatted and different. So this time years old will be the least significant factor and will go out. And we'll run the model again. Well, the largest p-value now is 0.02. We can consider that a significant variable at 5% significance, or anything greater than 2.4%. Since all variables are considered significant at this point, we can stop and say this is the best regression model we can get out of this data. Variables, baths, square feet, miles to resort, and acres are the model, and here we have the intercept and coefficients of the variables, and we can construct the regression equation.